Assalamualaikum students. Today our topic is short question answers of chapter number 11. Question number 1 is identify which part of these musical instruments vibrate to produce sound waves. Number 1, electric bell. In electric bell, armature and hammer, these are responsible to produce sound. In loudspeaker, diaphragm is responsible for the production of sound. In piano, strings are responsible. In violin, strings are responsible. And in flute, air column is responsible for the production of sounds. Question number 2. Why sound waves are called mechanical waves? Mechanical waves are waves that require a medium for their propagation. As sound needs a medium to travel, so they are mechanical waves. Question number 3. You and your friend are on the moon. Will you be able to hear any sound produced by your friend? Answer is no. I will not be able to hear any sound produced by my friend while staying on the surface of moon. Actually, surface of moon does not have any atmosphere, and as we know, sound needs any medium to propagate. Due to lack of medium, sound cannot travel on the surface of moon. Question number 4. Why the voice of woman is shriller than that of man? The voice of woman is shriller than that of man due to higher frequency of voice. The frequency of voice of woman is higher than that of man. Therefore, voice of woman is shrill and having the high pitch. Question number 5. What is necessary condition for the production of sound waves? There are two conditions for the production of sound waves. The body must vibrate for production of sound, and number 2, there must be a medium for the sound to travel through, like air, water. These are the medium which require for the production of sound. Question number 6. Sound is form of wave. Give at least 3 reasons to support your answer. Answer is that number 1, all waves are having the property of reflection, diffraction and refraction. Since sound can also manifest the same phenomena, so sound is also a wave. Number 2, second reason is that sound waves have the property of interference. In constructive interference, louder sound is produced, and in destructive interference, inaudible sound or reduced sound is produced. So this support the answer. Number 3, sound carries energy from one medium to the other medium. That is also a property of wave. Hence we can say sound is a form of wave. Question number 7. If pitch of sound is increased, what are the changes in the following? Frequency increases with the increase of the pitch. Wavelength decreases with the increase in pitch. Wave velocity, it increases with the increase in pitch. And amplitude, it remains same with the increase in the pitch. There is no change in amplitude by increasing pitch. Question number 8. Why two tin cans with a string stretched between them could be a better way to communicate than merely shouting through the air? Yes, It is better way to communicate because the sound waves have high speed in solids than air, and also the maximum intensity will be transferred through the string. But in case of air, speed is slow and intensity will be spread over large area. Question number 9. We can recognize persons speaking with the same loudness from their voice. Is it possible? Same loudness, but we can recognize them both. We can recognize persons speaking with the same loudness from their voice because their quality of sound is different. The waves form of sound produced by persons are different, so their quality is different and they can be distinguished from each other due to quality of sound. Question number 10. You can listen to your friend around a corner, but you cannot see him. What is the reason? The sound waves have larger wavelength. These are diffracted by the corner of the wall. So due to diffraction property, without seeing the friend, voice can be heard. Question number 11. A student says that two terms speed and frequency relate to same thing. What is your response? Answer is that they are different terms because we can define speed, distance covered by the wave in a unit time, and frequency definition is number of waves in a unit time. Therefore, both are different terms. Question number 12. Two people are listening to the same music at the same distance, but they disagree on its loudness. One say loudness is higher, other say loudness is not higher. Explain what is the reason. They disagree on loudness because loudness of sound is a characteristic which depend upon the physical condition of ears of the listener. A sound appears to louder to a person with normal ears as compared to a person with defective ears. Question number 13. Is there any difference between echo and deflection of sound? Answer is no. There is no difference between deflection of sound and echo, as echo is defined when sound is incident on the surface of a medium, it bounces back into the first medium. This phenomena is also called reflection of sound. Question number 14. Will two separate sounds of 50 dB together constitute a sound of 100 dB? Answer: no. Two separate sounds together cannot constitute a sound of 100 dB because dB means decimal. Decimal is an exponential scale. Each 10 dB increase in the sound makes the sound 10 times louder. An increase of 50 dB makes the sound 10 power 4 times louder. Hence it will not make 100 dB but twice as loud as the increase of 10 log 2, which is equal to 3.1. So 53.01 dB is twice as louder as 50 dB. Question number 15. Explain how sound is produced by a school bell. When school bell rings, longitudinal waves are produced. A series of compressions and rarefactions is responsible for the production of sound waves. Question number 16. What is silent whistle? Silent whistle has frequency ranging from 20,000 Hz to 25,000 Hz. It is silent for human because human frequency range is 20 Hz to 20,000 Hz, but not for dogs because audible frequency range of dogs is much higher as compared to the humans. Question number 17. What would happen to the loudness of sound with increase its frequency? There will be no effect on the loudness, only pitch will increase. Now examples of unit number 11. First example 11.1. Statement is calculate the intensity level of faintest audible sound and rustling of leaves. In solution, intensity level of faintest audible sound can be calculated by putting I is equal to I naught, which is equal to 10 power minus 12 watt per meter square in the following equation, because faintest audible sound have intensity 10 power minus 12 watt per meter square. By putting this value in this formula, intensity level is equal to 10 log I over I naught dB. By putting these values and simplifying it, we will get intensity level of faintest audible sound will be 0 decibel. And in second part, the rustling of leaves has intensity 10 power minus 11 watt per meter square. By putting this value in this formula, intensity level due to rustling of leaves will 10 log 10 power minus 11 divided by 10 power minus 12. By simplifying this, we will get intensity level due to rustling of leaves is equal to 10 dB. Example number 2. Very simple example. Calculate the frequency of sound waves of speed 340 meter per second and wavelength 0.5 meter. Speed of waves, which is denoted by V, is equal to 340 meter per second and wavelength lambda is 0.5 meter. By putting this value in V is equal to F lambda, we will get frequency is equal to 680 Hz.